welcome. So in this video, I will try to explain the plane angle and the solid angle in the easiest possible way, right? So let's first go to the plane angle. As you see in the figure, I have taken here a unit circle, a circle of radius 1, and then a circle of radius r. This yellow color, it is a circle of radius r. And both the circles are concentric, they have the same center and are enclosed by a two-dimensional plane figure. So this is a two-dimensional plane figure. It can be of any shape, just like a map on a plane of any country, right? Now we have to explain what is a plane angle. I am taking here 2 points on this random figure, a closed two-dimensional figure, P and Q. And from this P and Q, I take two line segments and join them with the center of these two concentric circles, right? So one line is this and another line is this. Now, these two lines will intercept some arc on the circle of radius r and on the circle of radius 1, that is unit circle. Then what is a plane angle? In the easiest possible way, we can say the arc length intercepted by these 2 points P and Q on the plane figure on the unit circle is a plane angle. So theta, this theta is equal to the arc length on the unit circle. But by definition, on any circle, the theta is defined as the ratio of arc length intercepted to the radius of the circle. So it is on this circle radius r, it is the arc length AB. So it is arc length AB divided by r. So that is L divided by r. Okay. Now, if this L is equal to the radius of the circle, that is L is equal to 1r, then what will be the measure of the plane angle? The measure of the plane angle is theta is equal, L is 1r, so it is 1r divided by r, so that is equal to 1 radian. Radian is the unit of the plane angle. Similarly, if this L is equal to 2r, so from this point to this point it is L, so then if we go to here and this is equal to 2r, so from A to say point C, it is equal to 2r, then that means from this point to this point, the length of the arc is equal to twice the radius of the circle, then theta is equal to 2 radians. But if we go for the complete circle, then L will be equal to 2 pi r. So then by definition, theta is equal to 2 pi r divided by r. So that is theta is equal to 2 pi radians. So total plane angle subtended by any plane figure at a center is equal to 2 pi radians. That is equal to 360 degrees in degree major. Or we can say the 2 pi radians is equal, since pi is equal to 3.14, it is the ratio of the circumference of the circle to the diameter of the circle. So that is 22 divided by 7, and up to 2 places of decimal it is 3.14. So we can write 2 into 3.14 radians. So theta is equal to 6.18 radian. So total solid angle is total plane angle subtended at the center of a circle is equal to 6.1 radians. So this is the concept of the plane angle in the easiest possible way. Now let's use the same analogy to explain what is a solid angle, right? So in this case again, I have taken two concentric spheres now. So these are not circles, these are two spheres. One is a sphere of radius 1, that is a unit sphere, and second sphere is the sphere of radius r. And both these spheres are enclosed in a three-dimensional closed figure of any shape, just like a potato or a boulder or any rock, right? So if we go inside the rock and imagine two concentric spheres, or we go inside the potato or boulder and imagine two concentric spheres, one of radius 1 and second of radius r, we can explain with this what is a solid angle. Now, what is a solid angle? If I take here a surface element on this three-dimensional figure, say this is the surface element. From this surface element, I take various points and join them with the center of these two concentric circles, concentric spheres, right? Okay. Now, these various points, when joined with the concentric spheres, they intercept some area. So they intercept some area on these two spheres. The area intercepted here is this, and area intercepted here is S dash, and here it is S. Now, the area intercepted or the cone formed here on this sphere or on this sphere is simply the solid angle. So we can say then omega, which denotes the solid angle, is equal to S dash, that is the area intercepted by this surface element on the unit sphere. So on the unit sphere, the area intercepted is equal to S dash. So this measurement of area on the unit sphere is the solid angle. Or if we use the definition of the solid angle is omega is equal the area intercepted on the sphere divided by square of the radius. Okay. Now, if we use this relation, now for S equal to 1 r square, if this S is equal, if this area is equal square of the radius, then in that case, omega is equal to 1 steradian, right? And similarly, if this S is equal, it is 2 r square. So that means if I go from this point to this point, or say up to this point, so then area intercepted is, say, suppose 2S. So in that case, we can write here S is equal to 2r square. So if this S is equal to now 2r square, then omega is equal to 2 steradians, because using here, so it will be 2 steradians. Similarly, if we now look for the complete solid angle, so complete solid angle, the total solid angle subtended by this three-dimensional closed figure, just like a boulder, so that is equal to 4 pi r square, because various points when joined from all the surface of this boulder to the point O, so it will enclose all the area on this sphere. So in that case, S is equal to 4 pi r square. So omega is equal to 4 pi r square divided by r square. So omega is equal to 4 pi steradians, means the total solid angle subtended by any closed figure of any shape is equal to 4 pi steradians. We can take here an example. For example, we have here a regular geometrical figure that is a cube of, say, edge length A. Now, what is the solid angle subtended at its center? Since it has 6 faces, so I am writing here 6. Now, solid angle subtended by each face is 4 sine inverse 1 by 2. So that is equal to 6 times 4. Sine inverse 1 by 2 is pi by 6. So 6 and 6 cancels, we get 4 pi. Now, how this sine inverse 1 by 2 comes? So that will be the topic in the next video. So we will calculate the solid angle subtended by a cuboid by any face at any point.